All right, okay, so we did a bit of introduction already. The main part of this talk is about .NET Core, and we'll talk a lot about runtimes, platforms, frameworks, and more. And then we'll switch to .NET Standard and look at what .NET Standard is all about. Who of you has been on the journey with .NET Core already? Who looked at .NET Core? Oh, yeah. Don't be afraid, it's okay to admit it. Anybody running any production code with .NET Core? There's 5, 6 people of it. Okay, so you know about the discussion zone where we can go afterwards? The people that raise their hand, if you want to, come meet me afterwards because I really want to hear what it's like to work with the latest bits and keep up to date and everything. Okay, so I'm going to keep the introduction fairly short. I do want to mention, and you might have noticed as well, that Microsoft is now a new company. It's doing all this innovation. It's on the hardware side with the Surface Studio, but it's also the way they want to deliver software. And traditionally with .NET Framework, it was a slow shipping vehicle, and now they want to push out their new stuff faster than ever. So they drive innovation, hardware and software. And it's out in the open, so most of what you're seeing today you can get at the GitHub. It's the big place where there's various repositories where you can get the latest bits yourself, build them. Usually they just build fine by just a simple build command, and then you got your own version of it. There's daily builds there, nightly builds, to get you all started. Microsoft is doing more in the open source world. They joined the Linux Foundation as well. So there's a new Microsoft, and they have moved away from just Windows, and they moved out into or servicing other operating systems as well. So Linux, Mac OS, those are the first two that they target now. And with that, they are now able to span a vast majority of machines, of devices, of platforms, just because they have more operating systems and more devices that they can target. Okay, so you might have seen about .NET Core previously, and I'm here to talk about .NET Core again, but a lot has changed because the way they are pushing things, .NET Core is changing while you look at it. So from one day to the next, sometimes things are all of a sudden different. But it's also nice because you can, if you keep up with the latest things, then you're ahead of the game and you can just watch how things are going. Okay, what we have here is .NET platforms. Microsoft doesn't generally talk about .NET platforms as a term, but it's actually the one you know, .NET Framework. The framework is the thing, the libraries with which you build your applications, but there's more to it. There's an SDK, which gives you the tools, the compilers, and that's the .NET platform. That's the oldest one of the full .NET framework. That's the one on the left. And then you have the cross-platform part of it that started way back. That's the Xamarin one. So in Xamarin, you have a re-implementation of some of the parts of the .NET framework code. So they took the code, ported it to a new platform, made it specific to the platform. And in the case of Xamarin, using Mono. Mono is a cross-platform implementation, mainly focused on ASP.NET and web scenarios, but it's able to run on Mac and on Linux as well. And the latest one, the newest .NET platform is .NET Core. And .NET Core is a reimagining of what the .NET framework would look like if we were to design it now. It started with ASP.NET 5, and Dino took you on the journey that from ASP.NET, MVC, to the new MVC and Web API, what the team did to make it happen. So they envisioned ASP.NET 5, wanting to break down system web into smaller chunks, and that just got bigger and bigger, and then all of a sudden they wanted to break .NET Framework, the full .NET Framework, into smaller chunks as well. And that's what's now called the Core FX, or the Core Framework. There's other .NET platforms. They're not all listed here. There's Windows Phone, you've got WinRT as well, and you've got newer platforms arising as we speak. But they do want to converge, because as the number of platforms grow, also the challenges of keeping up to date and keeping them all in sync grows. And so they've already started with the runtime components and the compilers. Underneath all of it is now the Roslyn compiler platform that does all of the compiling. And they've switched to Nuget Packages as the main delivery system for all of your dependencies. And also the parts of your compilers, runtimes, and the framework libraries. And on top of that, you can build your applications. So the base class libraries are just the basis. That's the types that you will need: system objects, strings, collections, XML support, network support, whatever you need. On top of that, there's application frameworks that allow you to build real applications. Dino talked about ASP.NET 4.6, which is just one of them. And there's a whole variety of application models that you can use. And on the right side, you can see that you can actually build applications for Android, tvOS, macOS. Thissen is a new one, the smartwatch from Samsung. So there's a whole vast new options and possibilities there. Now zooming in on the .NET Core, starting at the bottom, there's a couple of runtimes. And the neat thing that they did is they introduced this runtime adaption layer, which is a common ground on top of which they can build and run the CoreFX libraries and all of your code as well. But underneath there's this runtime that's able to be switched out. So when you are building your applications, you will actually use the same CoreFX regardless of the operating system you're running on, but you will use a specific runtime for your operating system. So yeah, that's the trick, that they have multiple implementations for the CoreCLR, the common language runtime, and even a special dedicated one, CoreRT, that's used in a .NET Native scenario, and we'll talk about that as well. Then the CoreFX libraries in the middle, the blue box, it's the base class libraries, but then it's all small in size. Many Nuget packages is what you will need. And if they're installed on your system, it's called a shared framework. And then finally, it's not in the picture, but it's the SDK, which gives you a set of tools that allow you to build the application, and you can do it from the command line. So there's a command line interface, the CLI, that allows you to build, pack, and deploy your application wherever you need them to go. So, in case you haven't seen it, let's have a look at a typical Hello World. So in this empty directory, there's nothing there, and what I have installed is the .NET framework for CoreFX, the SDK. Let me see if I can quickly show you. I believe it's here. This is the Github repo. It's github.com/.NET CLI. There's all the code, so you can build your own version if you wanted to. If ever somebody says, I'm running Linux because I can patch my own kernel, well, you can run CoreFX and the tools and patch it yourself. And please do pull requests, because Microsoft is actively accepting additions and fixes from the community. But if you want to be adventurous, you can go here and you can get all the latest build. Now these change every now and again, because they're almost lightly built. But they're fairly stable. It's preview 5 now. I'm not running that, but you can see if you've got them installed, you should be able to use the .NET. The team names it the driver, and it's a weird term for just an entry point to do all of the commands, the verbs that you can run. If you run it like this, it spits out a lot, but it's actually, it's also the start for your application. So if you ever see this, and you might run into this, it says, well, you should install the SDK. You might not have the SDK installed, but in case you do, you should get a lot of verbs that you can use after .NET. If you want to see the version that you're running on, there's a small minified version kind of thing, and there's a more elaborate thing on which operating system you're running on as well. So this gives you what are we running. So we're running preview 4, not the latest one, but it should be okay. And then we can just scaffold a new application, and each of the commands has additional help as well, and we'll do a .NET new, and we'll do a type of console, which is also the default. But after that, you got a couple of files here. Now, if you've done this before on preview 2 and up to a certain point in preview 3, you would get a project JSON. It's not there anymore, it's a CSproj now. But the rest is, well, the same. And we'll, just for editing purposes, we'll do Visual Studio Code. Visual Studio Code is cross-platform as well, so you can run it on Linux, on a Mac, and in this case on Windows. Even though I'm running a Mac, that's okay. So let me just put some code here, just to make it slightly less trivial. Now what this does is it actually just concatenates all of the arguments that are there, the arguments that come into the static entry point of this application, and it lists out everything inside of this directory. And that's the install directory in case you're running 64-bit of .NET, .NET Core that is. It would be program files x86 if you're doing the 32-bit version. So there we go. We need system.io. Okay, now go into the CSproj file. It's not the CSproj file that you knew from before. It's a new version, and we'll talk about that in a second as well. But I want to point out a couple of things that are of interest. First of all, there's this new thing called the target framework, because we need to specify what we're targeting. Then there's this wildcards here that allow you to just easily bring in all of the files that are needed to compile your application. You don't need to specify each and all of them individually. It's just wildcard inclusion and exclusion if you want. And then there's these package references, which do not reference assemblies, which you probably still could, but you would want to do reference to the names of Nuget packages in their particular version, and you can use wildcards in there as well, so just a particular version and up. With this, let me just save that out. Now that we've brought this in, we need to get the Nuget packages, so that's .NET Restore. And then we can do a .NET build. So it just builds out, it just gives just a tiny bit of information, just that it built this assembly. You can do more things here. You can do a bit of additional information, like normal verbosity, and it will give you more. You can even do very detailed output. And you can pipe in a lot of other things that would go into the MS build system as well. And finally, if you do .NET Run, you will run the application, and it will just list out the directories that are in the .NET installation location. These two are particularly important, SDK and shared. You can pass in extra arguments, so if I would do arg1, arg2, you will actually see them show up here as the arguments inside of the static entry point. So this will get passed in. So if you're running your application, and be aware of this, every .NET Core application is a console application. So there's no other applications yet. It might spin up a UI, but it starts as a console application. So they all have the static entry point. And this is how you get the information in. And then you could also do something like this. .NET, so going back to the beginning where I said .NET can also execute an application. So if you do bin debug net core, that's the target that we built. It's in this directory. And then we have this file there, the DLL. We can just bootstrap that and kick that in, and we can pass the arguments again as well. Okay, so maybe you saw a couple of new things. Let's see what we saw. So first of all, MS build. The CSproj is the first indication. The team decided to switch back from Project JSON, which was .NET Core specific, because they found two things. First of all, they saw that they needed to do a lot of investment to bring everything that MS Build already knew into the way they would build Project JSON files as well. And the other thing is that referencing between the various flavors of projects, or the Project JSON projects and the MS Build CSproj projects, they would have a hard time referencing each other. So they decided to unify it again and switch back to CSproj. There's, in the driver, you can kick off this verb migrate, and it will actually help you convert your project JSON into a CHproj again. They updated the CHproj file format as well, and as you saw, there's hardly any GUIDs anymore. It's readable. It has some new tags and elements in there as well, but most of the constructs that you know, like conditions on your framework or platform, you can still use it. And it's also a cross-platform implementation, so you can run MS Build on your Mac or Linux machine as well. So that's deprecated. You need to do the migration, and then you should be good to go. Because the project system is on top of the underlying source files and compiler platform. So you can switch out the way you actually build or tell the compiler to build your application. MS Build is now underneath all of the tooling. So if you're using Visual Studio, whichever flavor that is, or you're using the command line interface, the underlying MS Build is your entry point there. Now it's all about Nuget packages, and the way that the CoreFX is organized now is that there's a lot of small packages. In general, there's one assembly per Nuget package, and the assemblies have been made so small that they sometimes resemble a single namespace instead of just system DLL. Some of those are still there, but you can see here that, for example, there's system IO compression zip file. It's that small, that's only zip file, so you can pick and choose whatever you want. But it means that you have to reference a lot of assemblies or Nuget packages just to get started. So what they did is they made meta packages. And that's where they created, for example, net standard library. It's an empty Nuget package, and all it does is reference other Nuget packages. And they get pulled in if you reference net standard library. There's a couple of other ones, the Microsoft Net Core app. It's one that's even including the net standard library. And there's two other important ones in the biggest red box. It's the CoreCLR itself, that's also a Nuget package. And it's the .NET host policy, which is a platform-specific implementation that tells .NET, the host, how to find the current framework and to bootstrap everything. This is what you typically need to get started. The Net Core app meta package includes a lot of other things that you will probably need if you build a serious console application or start building a web server. But for the web server, ASP.NET Core, MVC, Web API, you will need to have the application model Nuget packages. And then you can do multi-targeting, so you can not only target .NET Core, but you could also target against the full .NET framework or against UWP or any of the Windows Phone if your code is compatible with those targets. There's a full list of all the target framework monikers, TFMs, that they have. You can see them in source code, but there's also on the website you can actually find all of the frameworks that you can target, and it's a fairly long list. So you can target just about any version of the full .NET framework. You can target Net Standard, which we will talk about as well. And for now, you can target .NET Core applications, which is just the first generation of .NET Core apps. There we go. Okay, and then the next thing is that besides targeting different frameworks, which are sometimes tied to a particular platform, even operating system, if you do .NET Core, you can go across operating systems, but you need to specify the runtime that you need, because you are targeting, for example, a specific Ubuntu or Red Hat distribution. And then you might have some special implementations in assemblies, which need to be picked from your Nuget packages. So, and the runtime needs to be adapted for it as well. The list there is pretty impressive already, but there's more and more coming. And they're also working on ARM support for Raspberry Pi, for example, that's being worked on now. There's people from RavenDB and from RhinoMox out here, and Allende Rahim, or an INI, is working on a ARM-compatible Raspberry Pi runnable compilation of the .NET Core stack. So talk to them if you want to find out more. The way you specify your runtime is through a RID, R-I-D. And the RyuJITs are just these monikers, these small names that allow you to specify which version you're targeting. There's some form of consistency there in the naming. You can find them in the runtime JSON file. That's part of a Nuget package. So Microsoft Net Core Platforms only contains the single JSON file. And it's a huge list of all the runtime identifiers. And they use this hierarchical sort of inheritance type structure. It's reversed in the tree up there, but it starts at any, and then it specifies the various framework flavors, and then it just adds more and more specific versions on top of it. It uses the import statement to say that if you're using OS X 10.11 x64, it's actually almost as if it's 10.11 or 10.10 x64. So it builds on top of that, but adds specific stuff. And there's a couple of ways that you deploy your applications. The first one is that you're doing a framework-dependent one. Now remember that there was this shared folder that we just saw in the installation directory. In there, there's all the DLLs that you would need if you installed, or if you would run your application, but not bring all of the assemblies yourself. So if it's there, you can just you can run your application by just the single assembly that we had, sometimes with a runtime config JSON file added to it, but those two are enough to get it started. And it's very, very small, so you can have a lot of applications, and there's a benefit from not having to bring in all of the Nuget packages for the CoreFX framework itself. It's almost as if you've installed a full .NET framework. You can rely on it, but you don't have to. It's installed in the shared folder, and you can see that and this is a screenshot from my machine. I have two versions there, a release candidate and a 1.0.1 version. And there's a way that the correct version gets selected with the .NET host policy. The other thing that you can do is you can do a self-contained deployment. And with a self-contained deployment, you bring everything inside of your deployment folder. So not just the DLL, the single assembly that you build, or all of its dependencies, as was the case in the framework-dependent one, but also all of the CoreFX and everything that is the runtime for a particular system. So it's self-contained, it's targeted for a system, operating system, and it gives you full control of what you have there. All you need is a machine that has the native OS dependencies installed, like OpenSSL on a Mac. You need to install it. It's not a Microsoft thing. But if that's installed, you can just X-copy the folder, and you're good to go on a clean machine. And that's very useful if you start looking into Docker and the container support. That's what you can actually see in the build-up of the Docker base images, that you can have a clean image or a clean image with the .NET Core shared framework already installed. So you can deploy a tiny bit or just everything and be very much in control. The command line tooling that we talked about, if you see articles that talk about DNX and DNVM, that's the .NET execution engine or environment, and the .NET version manager, that's the old stuff. So forget about that. I showed you what is out of the box, but you can actually extend an application by using new tooling. And it has a convention, so we will shortly run this in a moment, a .NET Sdk list, by naming your application like that, and if it's registered like that and findable, you will be able to have a new verb, just like new, restore, and build, but then Sdk list. So let's see if we can actually build that quickly. Now, to save some time, I've gone ahead and let me see. I've already taken the example that we had and did some additional stuff to it. Okay, so what did I add? We started with the target framework already. What we're doing now is we want to first publish this application as a standalone thing, and then we want to wrap it in a Nuget package so it can be installed as a tool as well, so the two stages. And for a Nuget package, you would add a version prefix, so you get this nice versioning, semantic versioning scheme inside of the name of your package. And I've also specified this list of target framework monikers. It says target framework, but it's actually the operating system, to be more precise. So you can see that we're targeting 64-bit versions of OS X, Red Hat, and Windows as well. Windows 7 means it's just compatible with 7, so it goes up to 10 as well. I also added this thing that's in the output folder of your compilation. It's details on what is needed to run your application, and all it says, I need the .NET Core framework. And then finally, I added a Nuget package, which is the CLI utils, and this is what you can use to add some code that allows you to interact with the command line interface tooling. That's all the changes in this file, and here I just added these 3 new things here, starting with the muxer, and I thought it was such a cool name for a class. This is the entry point. This is .NET.exe. That's the muxer, and that just veers off into whatever it needs to do. So we try and find the muxer path, because it could be in program files x86, depending on your 64 or 32-bit version, and we get the directory name from it, so that should be program files. The muxer path will be program files, .NET, .NET.exe, and we take the directory name, append SDK, and we see the insides of the SDK folder. Now, we can just run this, I think. Let's do a restore, just to make sure we got all the packages. Okay, and now we do a .NET run. Oh, wait up. Yeah, that's... okay, let me just wait up. Let me fix that. Okay, let's see. I might know what was there going on there. Build, does that work? Yeah. It's take. Oh, there we go. We fixed it. Luckily, whoa. Oh well, that doesn't deserve an applause, but thank you anyway. This is all of the SDK versions that are installed, and you can even switch back to the previous versions. You would need to define a global JSON file in the root of your solution structure, and if you just specify which one you want to pick, the .NET.exe will actually use the tooling that is there. So you can switch back to preview 2 and do the project JSON style of working. It's still there. So that's interesting to know what is just there. Okay. So with that working, let's do a Control-Z here, because I do want to show you that we can now do a publish. And with publishing, I will just put out everything. And let's quickly take a look at what is inside of the bin, debug, netcore, what is there. It's this set of files. So there's the assembly, the program database for your debugging, and some dependencies and a runtime configuration. This is the one we also included for the Nuget package. And I've already gone ahead and published various versions of the application targeted for these particular runtimes. You would do so by doing a publish, and you would just pick whatever you would like to have. So .7.2 minus x64, and that would just jump into that folder. Oh yeah, because we know that this is oh well, it happens to me all the time. Because I specified runtimes, and they weren't there before, the runtimes are Nuget package based as well. So now I was just saying, I don't know what you're talking about, but you need to do a .NET restore as well. And thankfully, if you use Visual Studio, it will do all of that for you. But then the publishing should work a little bit better. So no fancy output. But it does actually bring us to this point. Let me see, we'll do a Explorer from here. There we go, SDK list, bin, debug. And then we have, let's pick one, let's pick this one. And I'll make it a bit bigger. There we go, publish. So now we have a couple of files there, but we've got also some other files, all of the dependencies, and everything that's CoreFX and runtime related. And I do want to point out a couple of special ones, like these two. So the globalization extensions, there's a native SO. Remember the native SO. There's other ones, like, for example, on the system cryptography, encoding, and all of the other things. And then there's native SO. And SO are DLL files on the Linux operating system. Yeah, I'll skip the part with, or do we want to see the packaging stuff? Let's just try to be real quick there. Make directory app with tool. Oh yeah, and we need to do something. We need to do a .NET pack output to this folder here. So I'm outputting it outside of our structure. And now I've created a Nuget package there. Trust me, it's there. Let's assume it's there. And now we want to start using that as a new tool for the command line. So let's do .NET, new language F#, just for fun. We do a code dot. There we go. We have an F# file. I'm not very proficient, but we can do that one. And here we have tooling references. So this is the way the tools are referenced. And the F# compiler is actually listed as a new tool here. And let me just add a couple of things quickly. I need this bit. There we go, new tooling. And we need a reference to the Nuget source that we just created, because it's a folder and we just add it to the global sources. Save out everything. There we go. And do a .NET restore again, because we added new tooling. And this will install the tooling for the F# compiler, parts of it, and also for our tool. And now that we've done it, we might, if we're lucky, do .NET SDK list, so without the hyphen. That was the executable name, but now that we've installed it, and it's installed in this special place, it's installed inside of packages. Here's the two Nuget packages that were pulled down on the restore, and here's the tools directory that actually put our stuff there. And inside of the SDK list, that's our prefix, our target. It's not there, so it will probably not work. Oh. So this will fail, I'm sure. Oh, it does work. Oh, okay, so I missed something. It might not have, it does not have the things installed because it will look in the Nuget package folder. So now we can have, this is an extension to the .NET driver and a new verb. So you can do your stuff there, and others can do that for their tools as well. Okay, so we saw the SO files on the self-contained deployment for Red Hat. If you compare all of those, it's interesting to see that there's assemblies that are specific for Windows. You see that there's the regular set of things that we compiled with our project. They're there on OS X and on Red Hat Linux as well. So this is your framework-dependent deployment. If you would deploy this and the rest would be installed, you could run it. If you need a runtime for Windows 7, you need you can see CLR thing, so that's the runtime stuff, CoreCLR, the JIT elements, and then it goes into the host framework resolver and the host policy files. It looks different on the OS X because they use dylib files instead of DLLs, but it's essentially the same files with a different naming convention. And the same goes for the SO files on a Linux box. And they can be somewhat specific to a particular distribution of Linux or OS X for that matter. And they did some smart things because there are so many variations of Linux distributions that they created platform agnostic packages all the way at the top that they can run anywhere because they have no ties to the underlying system. And then they created the dark blue ones, which just do platform invoke calls into the drivers that are at the operating system level. This is for Windows. And if you look what they did for Linux, They actually have indirection there. There's this middle blue layer, that's the SO stuff. So the system native and the cryptography native and globalization native that I said, remember those? Those are the ones. They do the platform invoke calls from the dark blue ones into the shims. Then they do nothing but just target the specific libraries that might just vary per Linux distribution. So they don't have to change the dark blue ones all the time. They just do the SO native stuff. So it's a bit of a smart choice there, and that's why you can find them. Now the versioning, they have two versioning strategies. There's the long-term support, LTS, which they refer to as being the chill, because you will follow along with the 1.0, the 2.0, and it's just a regular pace, and you get 3 years of support for that. If you want to be more on the exciting track, and those are the terms of the inventors of .NET Core, then you would do current, and that's the 1.1, 1.2, or the minor increments. The host policy and the way the framework is resolved, it will actually pick up, using the semantic versions, it will pick up on the latest version with the patch number, so the latest digits. So if you have 1.0.0 when you compile your application, but a system has 1.0.1 of the CoreFX and Runtime installed, it will automatically start using that one, because it can include security patches and bug fixes. But it will not do so with the 1.1 or 2.0. You have to be explicit about it. By using the meta package that we saw earlier, Microsoft Net Core app, you will just retarget that to be something like 1.1.0 if you want to switch to the current style. Or wait until 2.0 it comes along, but then you might have to do some more rework, which would be less if you stay current with the current track. If there's a new version of the application models, you just specify whatever new Nuget package that you have. Now the compilation models that are there, excuse me. There's the old and familiar just-in-time compilation that you use on a regular basis. So there's the source files, use the Roslyn compiler platform, and you compile them into .NET assemblies which contain IL code. And you can use Visual Studio or MS Build or the command line tooling, and they all use the same thing, MS Build underneath. And then you have your own assemblies, add to that the runtimes and your CoreFX, and then you're good to go with your application. Because once it comes to runtime, you can actually just spin it up with the .NET.exe as a tool. If you do a framework, a standalone deployment, you will find that there's an exe there, but it's just a renamed .NET.exe. So if you rename it back to .NET.exe, it's the same file. But it will load the CoreCLR, and you will load all the assemblies, and the just-in-time compiler RyuJIT will compile it into .NET native code. Thanks. And that's all done in memory, and it happens over and over again if you rerun your application. Does anybody know what Ryu means? Oh yeah, what is it? I mean, I wondered what Ryu is, and it turns out to be this dragon, this fast and legendary dragon. So it could be that one, or for the gamers amongst you, it might just be Ryu from Street Fighter. But it's cool anyway, right? That they gave a special name to the JIT compiler. Anyway, ahead of time compilation, it will just do the same thing again, but it will continue and do compile into a single executable with the CoreRT runtime in it. And it's a specialized runtime that doesn't have to do dynamic loading of other assemblies, because everything is compiled into the single executable. They do tree shaking, so they just shake the code that you have, trace whatever you're actually calling, get rid of everything else, and put that inside of your assembly. This is all you have, a single executable that's very small, and you can, there's other experiments now with LLILC, which is an LLVM-based way of compiling, and they have the C++ code generator. And I will leave it at that, because we need to make sure that we spend some time on .NET Standard, and we've got 10 minutes. .NET Standard is a specification, and it is mainly targeted for library developers. Because with all the platforms there must be a way to specify that there's common ground, because system string is available on every platform. And why does it need to have various implementation, or why do you need to learn? So The .NET Standard is a bunch of C# files, that's the specification, that just list out whatever is in the CoreFX or in the .NET Standard for you to work with. And it's different from the PCL, so the portable class libraries, in that they say, okay, this is what it is, this is the standard in a particular version, and a .NET platform can implement it or not. And if it does, it's compliant with .NET Standard 1.0, or maybe a modern one would be compatible with 1.6. But you know that if you compile a class library targeted for a particular version of .NET Standard, it will be able to run on that .NET platform. So it doesn't do all the funky profiles that you have for portable class libraries, where it's hard to predict if it will run or not, and it's all these weird intersections of platforms, just eliminating by the API. Now the API is set in .NET Standard, and it's the platforms that do or do not have an implementation for that standard. So they're guaranteed to work everywhere. And the way that's versioned now, it's predictable because it starts at 1.0 and it's incremental. And they promised, the team promises, so we'll have to take their word for it, but they don't do any breaking of backward compatibility. So it's, if it runs on 1.4, it will also run on 1.1. So you can just pick whatever you choose, but you're dependent on the .NET platform if they have an implementation of that standard or not. Has anybody seen this matrix before? Do you understand it? I mean, I still have trouble understanding what is there, but it lists out all the versions and the various .NET platforms. And you can just see by the intersection, if you want to target Windows Phone and you want to write a library for it, then you can only go up to standard 1.2. If you go to the site itself, it's the same matrix, but you can actually click the headers, so you can see what's inside of the .NET Standard. This is everything that is in there, and it's an empty implementation. It's a really large file. You will see this get compiled in the future into a single assembly that's called netstandard.dll. And that's the full specification of the .NET Standard for the compiler to reference and for Runtime to do some magic stuff. If we go back to the previous one, you can actually see what's the difference with 1.2. And you can see that they might change stuff, and you say, oh, but they didn't break anything. That's true, because it's actually it's incremental, so it's just more interfaces or more methods that are there. Now this is really important. If we have time, or maybe at the discussion zone, I'll talk to you about this metaphor with dancing, how you can use a dancing standard so you can dance in every dancing school, but there's less schools if you learn more steps. So that's kind of a way to think about the .NET standards in the interest of time. So going back to our .NET platform slide again, this is where Microsoft wants to go, because if CoreFX, for example, provides an implementation of what is in the specification of .NET Standard, that's the .NET Standard library, it should be able to run on any other .NET platform if they use the same .NET Standard, if they have the implementation underneath. So in the future, you might see that the CoreFX or the .NET Standard library is actually going to replace parts of the .NET Framework or in the Xamarin Mono BCL. And Mono is already, so the Xamarin guys are already doing that. They're replacing parts of their BCL, their own code, and just rely on CoreFX because it's compatible anywhere in the .NET Standard part, the .NET Standard library, that is. If you do an analysis of what you can do with the various standards, you will find that you run into some limitations there. You will have to use all the modern APIs, and there might be some missing. That's 1.6. So it's sometimes a bit challenging to take your .NET Framework code and compile it for .NET Standard 1.6 if you want to have an assembly library that you can use across platforms. But with .NET Standard 2.0, there's actually a lot of things coming back. So they do a couple of things. More APIs, so binary serialization is coming back. There's even the system.data support with all the abstractions, not the actual providers of SQL Server or what you have, but they do have the data row, data set, and so on. So there's more that you can rely on. And then there's another trick that they can do, which I can explain in more detail in the discussion zone, but it's about being able to reference assemblies that were originally made for the .NET framework, the full one, that uses MS Corelib. Because there's stuff in there, like system object, that's inside of MS Corelib with that identity, and the .NET standard version of system object is not the same one. So you can't call into normal framework libraries, .NET framework libraries, but you can with .NET Standard 2.0. And this is how it goes. So you have the various platforms. You can reference your standard library-based assembly that is there, because if the platforms implement a particular version, it's able to run on all of those. And from your library, you can reference other .NET Standard libraries that are the same version or lower. They should be compatible as well. You can reference a certain set of portability classes, portable class libraries, I mean, if they are within the bounds of your .NET Standard library. So there's a list of profiles available that just specify which profile numbers you can use from your .NET Standard library if it's 1.x, so under 1 versions. But if it's under 2 versions, small change in the blue box, then you can actually, through a compatibility layers with shims, they do this smart redirecting and faking, where you can actually redirect stuff with type forwarding into being able to call from your .NET Standard library into .NET Framework-based libraries. And that should accelerate the migration process, because you don't have to wait for the deepest dependencies to be migrated to .NET Core or .NET Standard, and then it goes up. Now you can just, for the time being, reference .NET Framework-based libraries and work with that. If you want to run your code through that, you better switch to .NET 4.6 if you still have the source code, and then you can use as much from that as possible for .NET 2. And you run the API port tool. And that's the last demo that I want to show you, because I took this bit of code that I had. It's about querying game servers. I play games in my free time. All of the shooters, Counter-Strike, Doom, Quake. And I once wrote, and it's Visual Studio 2008, so that's how old it is. I once wrote this library that is able to interact with the servers. And we're not going to run the code, but it's all these things with sockets and special stuff. So what I did was I used the analyzer, changed the portability settings, and I hope it compiles. Oh, I ran it already. Let me show you what happens. So it actually outputs some stuff. What I did was the settings. It's this huge dialog where you can just say, analyze if this is compatible with each of these frameworks. So I ticked a few boxes. It gives a report. And the report, if you open it up, it's Excel or other things. It says that you're almost good with .NET Standard 2.0. Just do that again. So 2.0 here, 99.6% compatible. But if you go to the details, you can see that there's some hints on what is supported and not supported. You can see that there's actually 2 things not supported. So the script ignore attribute is not supported even in 2.0. If you go to this HTML view, you can actually see that there's a lot of red dots there of the things that are not supported for framework version 1.6 or 1.0, but there's a lot of green ones for 2.0. So moving to 2.0 will allow you to use the old begin and end asynchronous support again. It will have missing methods that they got rid of because they thought close was not good enough as dispose, so they got rid of close. All your code should be revamped to use dispose. But that's just coming back again, and you have an easier time porting your code. So we've done the demo. Then finally, in summary, so if you're switching to .NET Core, I think it's still interesting from a variety of perspectives. Container support, if you're doing cloud-native solutions where you just want to have a small footprint and a lot of server density, go see what the .NET Core can do for you. You can even run it on container clusters with Linux because your code is portable in that way. You can use the .NET Standard to have this, this API surface. If you're a library developer or relying on libraries, that the .NET Standard will unify a lot and bring goodness. And in the future, if .NET Standard, which is still in progress, if it's coming along, your migration story will be a lot easier. And finally, just be patient and wait for the tooling to catch up, because they're doing finalization as we speak, and the tooling is catching up with all the fast changes in .NET Core and the SDK. That's what I have for you. Thanks very much, everyone, and I can talk to you at the discussion zone. Thanks.
Спасибо, Алекс. У нас есть несколько минут на вопросы. Если у вас есть вопрос, то вы поднимаете руку, я к вам быстро подбегаю. Если вы думаете, что вы быстрее дойдете вот до этого микрофона сами, то подходите к нему. Здесь он тоже работает.
Yeah, thank you, Alex. I have a question about, I think, the last slide or.
Can we switch back to the slides?
Oh, no, it's a summary, of course.
Which one was it?
About the compatibility metrics that you opened in Excel.
Oh, in Excel, this one here?
Yeah, basically. It's very useful if you have this information, but it's very inconvenient if you have to open it in Excel or in browser. Is there any way to highlight it right in Visual Studio or any other IDE?
Okay, so the question is, it's inconvenient to go to the tool, so in this case Excel or the spreadsheet. There's also a third option, that's the JSON support. So you could open that JSON file inside of Visual Studio, but in the end, I think I've done this myself. I've taken the library that you saw, and I just started. And what I found very useful, well, the Excel sheet is, I think, if you want to do metrics on it, but I found this to be very useful because it does list all of the problems that are there, and you can just find things. So, for example, if we go quickly to I hope I have a link here. I don't. Let me see. Package search. I believe this is the one. Yeah. So I found that, for example, I used a call to URL decode in HTTP Web Utility. So it's not supported anymore. So I wondered, what can I do? So that's the URL decode. I just do it in a reverse search. And it says, okay, these are the packages that you can now use that have a thing that does URL decode. So I pulled in those packages and got a different version of URL decode that did the same thing functionally. So that's how I upgraded the code. I got rid of the close methods, replaced it with dispose. I got rid of the begin and end and did async methods that sometimes the synchronous ones aren't there anymore. And going back and forth to the HTML page helped me out a lot to get started. So yes, inconvenient perhaps, but it's extensible, it's available, so you could write your own V6, your own Visual Studio extension, or Visual Studio Code extension for that matter, and have something more convenient. For example, built-in support for the reverse lookup. That would be cool.
Okay, we have time for the last question.
Hello, Alex. I don't know if you are the correct addresser of my question, but the question is quite simple. Do you have some information about the WPF compatibility for .NET Core?
Okay, so
the question is for you as a game player, first of all.
Okay. So the question is, what about WPF, Windows Presentation Support in .NET Core? Well, I'm afraid that's wait up. If we go back to something around here, see where the box is located? Down there, WPF. WPF by itself is not ported to .NET Core, and I think it might not be, but that's a personal guess. Let's call that. Because there's a replacement for XAML-based UI, and that's UWP, the Universal Windows Platform, with the applications that are built on that as well. And it's like this a newer version of WPF doesn't have everything that WPF has. It doesn't have printing support, for example, but it is able to span from IoT devices to your Xbox to the Surface Hub and even Windows Mobile. So that's what Microsoft is aiming for. They want to just WPF is there to stay. It will be supported. It will have a future. But if you want to get the reach across all of the devices and platforms, well, in this case, devices, Windows-based devices, it's UWP. That's your answer there. And I think you will see most of the games, as your particular answer, will start to be built on UWP because they can run on Xbox, but also on a Windows mobile phone. Linux, that's a good one. I think that this is tied to the Windows platform because it's universal Windows platform. So they're doing incredible stuff, porting things across different platforms as well. So we'll have to see what's happening in that space.